Okay, so week 12, the topic number 1 is ideal gas law. And ideal gas law is probably PV equal nRT. I've shown you here. This is one of my favorite RPI teachers. If you look at that, that means a P, right? So we got to use this equation. And one thing that to note is the unit to be used in ideal gas is defined by your choice of the value here, 0.0821 liter ATM per mole Kelvin. So therefore, your choice of volume should be liter, and the choice of the pressure should be an ATM. And now let's read the problem here. A sample of unknown gas with a mass. So mass is given for this sample, and that's a gas, decomposed into oxygen of certain gram and sulfur with a certain gram. So therefore, this gas must be composed with sulfur and oxygen, right? So it's made out of those. And then before the decomposition, this sample occupied the volume of this, so that must be your volume. And this is a centimeter Hg, and which can be converted into ATM pressure. That's your pressure, and then this is your temperature, right? So what do I have here? So we know that the volume. First of all, volume is 1.12 liter. Okay, I change it to that. And what about the pressure? Pressure was this is same as 750 millimeter Hg, and that's the same as a torr. So it's a 750 millimeter Hg, and then I know the conversion is 760 mmHg, millimeter Hg, is a 1 ATM. So finally, I have a conversion into a useful number, which is 750 divided by 760 ATM. What about the temperature? Temperature is now 75 degrees C plus 273.2, and that's a Kelvin. So that make it 25 degrees C. Sorry about that. So that's a 25 degrees C. 25 degrees C. So 298.3 Kelvin. So I have those numbers. So then what do I enter it now is PV equal nRT. So therefore, number of moles for the mass of certain this for mass of gas, that is whose 3.620 gram. Okay, N is 750 divided by 760. Volume is 1.12, 0.082, and 298.3. Then make it 0.0451 mole. So what it means is, for the gas whose mass is this, that corresponding to the number of moles. So therefore, I know the molar mass now. Mass of gas, who is composed of, let's say, sulfur and oxygen. So let me just say they're probably gas, sulfur, oxygen, X and Y, right? So those are the, this is something that we're going to figure it out later. But there's the one who has gram per mole, right? So 0.051 and 3.620. That make it roughly about 80.2 gram per mole. Okay, so I have a very crucial information that whatever the gas that we have in that container, it is their molar mass. But the other information that I have is, okay, so gas SY, those are two different combinations. It has a mass of 2.172 and then 1.448 grams of oxygen. Whether it's an O2 or oxygen is just we know that we can count the number of atomic oxygen. That's important here. Grams of sulfur. Okay, so that's an S. So then what do I do is instead of dealing with a mass ratio, I want to deal with 2 from mass ratio to mole ratio. So that's what I want to figure it out. So what do I do? It's a simple task because atomic oxygen has a 16 gram per mole oxygen, and then this is 32.7. Look at the periodic table, you can find out gram per mole sulfur. So therefore, if you do that, that's 2.172 divided by 16.00, then you will have a mole oxygen atom, and then 1.448 divided by 32.07, that will get you mole sulfur. And this is a very small numbers, and then now when you compare that, this one is the closest integer value is 1 to 3 ratio. Okay, so now I have a very important information, because one thing that I find out is this number is small, and once you have this number this number top divided by the bottom number, that becomes roughly about 3. So it's a 3 to 1 ratio. So this crucial information tells me that either the ratio in the molecule is either SO3 or S2O6 or S3O9, and so on, right? So that as long as you can maintain the 1 to 3 ratio, this is valid. But so now I'm going to put these two puzzles together. First puzzle is the ratio, 3 to 1 ratio, and then the total molar mass for this gas is this. And then by doing so, this one, the molar mass of SO3, as you can calculate, that's about 32 plus 3 times 16. That's about 80. Right? So it must be this one is what is known as a molecular formula of this gas. Right? So therefore, molecular formula of gas is SO3. Thank you.